This is Unit 4, Lesson 5, Outliers and Shape, and the objective of this lesson is students will be able to describe shape and spread. We have a few different vocabulary terms that we're going to go over, and the first one is outliers. Outliers are data values that are either much greater than or much less than other data in this set. And sometimes you can pick out outliers just by looking at a list of data, but there's a specific way that you can go through and calculate what the outliers are in a set of data. Our next three terms all describe the shape of a set of data, and the first one is symmetrical. Things are symmetrical if they're the same on both sides. So symmetrical data is data that is the same on the left and the right, or it's balanced. Our next shape of data is skewed left. Data that is skewed left is data with a tail to the left. On a curve, that would look like something like this. In a box plot, it would look something like this, where we have a long section going to the left, and then everything else grouped together on the right. We also have the opposite of skewed left, which is skewed right. And you can probably guess that this is data with a tail to the right. So on a curve, it would look like this, where you have a long tail going out to the right side. In a box plot, it might look something like this, where we're stretched out to the right. So let's move on and find out how to calculate an outlier. The first step to calculating an outlier is to determine the first and third quartile. And I've abbreviated first and third quartile with Q sub 1 and Q sub 3. That means first quartile and third quartile. Next, I need to calculate the interquartile range, or the IQR. We learned this in our last lesson, and as a reminder, that's done by doing quartile 3 minus quartile 1. Once we found the interquartile range, we need to multiply 1.5 by the IQR, or the interquartile range. This is going to tell you the expected spread of values. So it will tell you how high up the values can go above the median, and it will tell you how low down the values can go. So step number 4, to find out how low we can go, we do quartile 1 minus the number we just calculated here, 1.5 times IQR. Once again, that is quartile 1 minus 1.5 times IQR. Remember, in order of operations, this happens first. This number is going to tell you that data values underneath it are outliers. So any number less than what you calculate right here is going to be an outlier. Those are outliers on the lower end. We also want to look at outliers on the upper end. So we're going to do quartile 3 plus 1.5 times the IQR. When we do this, we're going to find data values, or the maximum data value that we can have before we get to outliers. So data values greater than this value are outliers. So to find the center of a set of data, you can use the mean or the median. If we have an outlier, you are going to use the median. The reason why we use the median is that outliers completely throw off the mean. It will make the mean a lot lower or a lot higher than where the center of data is concentrated. So now that we know how to find an outlier, let's go through a couple examples where we are going to find outliers and then use that information to describe the shape, the center, and spread. There's a group of 20 students who measured the length of their pencils, and the data that they collected is represented on this table. We are going to use this data to describe the shape, the center, and the spread. So if you take a look at your notes you just took, the first thing we need to do to find the outlier, which will help us answer all of these questions, is determine the first and third quartile. Well, I know to find the first and third quartile, I need to find the median. And to find the median, I need to list everything in order from least to greatest. So I'm going to go ahead and do that right now. Here's my list of data values ordered from the least to the greatest. The middle in this set of values is split right here between 16.1 and 16.1. So that's going to make my median right at 16.1. My first quartile is 15.6. And my third quartile is 17. And I forgot to add one of these little 15.6s right there. So there should be another 15.6 after the first 15.6. Okay, we found the first and third quartile. Now we're going to move on to step 2, which is to find the interquartile range. And the IQR, or interquartile range, is found by doing quartile 3 minus quartile 1, which gives me 1.4. The next thing I need to do is calculate 1.5 times the IQR. My IQR in this problem is 1.4. So when I do 1.5 times 1.4, I get 2.1. Now we are ready to find the outliers if we have any. So we do quartile 1 minus 2.1, and then we will also do quartile 3 plus 2.1. That 2.1 came from right up here. Well, quartile 1 minus 2.1 is 15.6 minus 2.1, which equals 13.5. And quartile 3 plus 2.1 is 17 plus 2.1, which gives me 19.1. So I need to look at my list of numbers up above and see, are any of the numbers below 13.5, which, yes, I have a number below 13.5. Are any of the numbers above 19.1? No, they're not. Our largest number is 19. So let's go ahead and write down that we have an outlier, and the outlier is that 10.2, because 10.2 is less than the expected range, which goes down to 13.5. So the objective here is to be able to describe the shape, the center, and the spread. Well, if I were to create a box plot, I would see that my numbers go from just below 10 and up to almost 20. They go up to 19. So my minimum is at 10.2. Quartile 1 goes from about 15 to about 17. The median is at about 16.1. And my maximum goes up to 19. Well, because there is this long tail over here, I can say that the shape of my data is skewed left. And because this part right here is so much larger than the other part, we can say that it has a large spread. And then finally, to describe the center, I'm going to use the median. And my median, I already know, is 16.1. The reason I'm using median instead of mean is that there was this outlier of 10.2. If I were to use the mean, it would give me a much lower center than I should get because this 10.2 kind of sucks the mean down. So my data is skewed left. My data has a large spread, as you can see right here. And then my data has a median or center at 16.1. We will go over some more examples in class of how to look at the data and decide the center, spread, and shape using outliers in the interquartile range.